But okay. All right, so anyway, so as I talked about last week, you guys technically should have done the periodic table 101 lesson last Thursday, but I just wanted to make sure that we had a nice little even split for how much content we're doing. So we're talking about periodic table 101 and then the patterns in the arrangement of electrons in your, I guess, in an atom. Okay, so your first lesson was on the periodic table 101. So it was basically just on reading and understanding what you're looking at when you're looking at the periodic table. So it is divided into 7 rows, or what we call periods, and then there's 18 columns, which are also called groups. So within each of the, I guess, little, if you want to call them squares, that has all the information that I guess is important, I guess at our level anyways, for each element. So on our periodic table, you're gonna look at this number here up top is the atomic number. This is also equal to the number of protons that are inside that element. So what it's saying here is that the number of protons is the exact same for all of that type of atom. So sodium, all sodium atoms will have 11 protons in their nucleus. This part here is the average atomic mass. And so we usually say the word average atomic mass, and that's because some atoms can actually vary in their weight. They cannot change the number of protons because then that changes the element itself. But what can happen is that they could have a different number of neutrons, which, you know, and having more or less will affect how much the atom weighs, which is, I mean, very, very small as it is. So what happens is they've just taken a number of, say, the different types of atoms, which we can call isotopes, and they just take an average mass of that. So that's typically only if you see brackets around that number. I can pull up the periodic table. There are some here, I believe that should have it. Yeah, especially down here. So we have lots here that are in brackets. So that just means that there's different isotopes of them, or there's different atoms that have different amounts of neutrons. Oops, wrong document. Okay. All right, so moving down here, this value right here is electronegativity. That you're actually going to talk about in chemistry 30, so you can completely ignore it. The reason why I use this periodic table is that way, you know, I was teaching the chemistry 30 and the grade 11 chemistry as well. And so I wanted to stay with the same periodic table so it doesn't change, so it doesn't become overwhelming. So just for right now, you can forget about the electronegativity. That has no impact until and if you choose to take chemistry 30. So the next part here is your atomic symbol. So that's just how we shorten up the element. So this one here, Na, is sodium. And so just remember your first letter is always capitalized, and then any letters after that will be lowercase. So we have capital N and lowercase a. If you're wondering where, you know, why we are shortening sodium to Na, sometimes it comes from the Greek or Latin name of the element, just because maybe S or SO was already used up, which in that case, I mean, if you look at the periodic table, we already have an S here for sulfur, and then I'm not even sure if maybe we have an SO, or maybe they didn't want to confuse SO with the word so. All right. All right, so there is also a pattern in your ionic charges in certain groups of the periodic table. And this here is actually a really important concept when you move into something called ionic compounds and understanding ions. So I guess we're going to go over some of the the most common patterns. So looking at your first group here, so this first column, all the elements in this column are going to have a +1 charge. So that just means that they've lost an electron, they've lost some negativity. If you guys remember from the lesson, an electron has a -1 charge. So tell me what happens if they have a +1 charge. Anything in this column here will have a +2 charge. So you have a 1 positive or a +1, 2 positive, and then we're going to jump all the way over to group 13 here. This one here has a +3 charge. So well, I guess, and I don't want to say anything, but most elements in this column here are going to have a +3 charge. Right here, column 14, you could say it has maybe a plus or -4 charge, but typically we just say that these actually don't have a charge. That'll make sense when you get to grade 11 chemistry. And then from here we go backwards. So now we're going, we went 1, 2, 3. And now we're going to go 3, 2, 1. But now what's happening is because now we're going backwards, instead of being positive, all of these elements are going to have negative charges. So it's going to be a -3 charge, -2, -1. And back here is, this one here is at 0. These ones here are your noble gases, and these ones here typically will not ever have a charge if they're in an ion state. But anyways, you should recap that in grade 10. That's a really important concept. And then, you know, it should be repeated probably in grade 11 as well, if you guys choose to take physical science. But kind of having an understanding of those charges is really important. But it's just one of those patterns that we were talking about at the time. So, okay. So that's the basics of your periodic table. So now the really important part is about to come. Probably the most important of these two lessons is the patterns in the arrangement of electrons. Okay, so all atoms, regardless of what type of element they are all going to have protons, neutrons, and electrons. So your protons have a +1 charge. So each proton has a +1 charge. Neutrons are, if you want to remember, they're neutral, so they do not have a charge. And electrons have a -1 charge. If you notice here, I put 1 negative. This is just how we would indicate the charges. We don't want to put a -1 or a +1, just because that can be confused as an exponent. So just part of those conventions of chemistry that we write the charges with the number first and then the sign or the symbol afterwards. So protons have a 1 positive charge, electrons have a 1 negative charge. So the outermost energy level, when we're talking about Bohr diagrams, is what, and we also call this the valence shell. This might just be, if you guys are doing some research, valence shell might pop up there maybe randomly. And anyway, so your outermost energy level determines the chemical and physical properties of that element. So you guys will look at that a little bit, I guess, in your chemistry grade 10 and 11, 12 sort of concepts there, but just a really important concept when we're talking about Bohr diagrams. But anyway, so we are going to draw Bohr diagrams. So a Bohr diagram is a representation of, I guess it's a way that we can represent an atom. And just to state though that, you know, when we draw the little circles, we're not drawing, or that isn't how an actual atom looks like. We saw in the lesson last week that it's just one of the most convenient ways of drawing an atom, but electrons typically exist in, say, an electron cloud.